From a dramatic crash of lightning to the jolt of an electric shock when touching a doorknob, or walking across a carpet, or when socks cling to other clothes, and Scotch tape jumps around your hand after you peel it off the roll. Static electricity is all around us. These everyday commonplace occurrences may seem rather insignificant, but the electronics industry has discovered a link between these occurrences and the destruction of thousands of semiconductor devices each year. The cause of this destruction is electrostatic discharge, or ESD.
The damage resulting from ESD is estimated to cost the industry billions each year. These costs not only lower profits, they affect our ability to compete in the international electronics market, and our competitiveness translates to jobs. That's why each and every one of us must be conscious of its cause and effect and how to prevent it. Those of us who access areas where static-sensitive items are found must go through basic ESD awareness training. This includes janitors, as well as maintenance and security staff. Those who actually handle the components are formally trained, certified, and must attend an annual review of the ESD Control Manual. People who handle our most static-sensitive products, also known as Class 0 items, must go through an even more in-depth training and certification process. These steps will eliminate the ESD threat and help ensure that our products are always of the highest quality.
Whoa, that was a big one. Static electricity doesn't have to be that dramatic to do some serious damage. I should know, because I'm Static Wizard. My job is to let you know how you can prevent ESD damage. But first, let's go over some basics. Static electricity is caused by friction. When two objects rub together or are pulled apart, one of the objects passes electrons to the other. The object that gains electrons becomes negatively charged, while the other becomes positively charged. ESD occurs when the accumulated charge is rapidly discharged to a third object. The magnitude of the charge depends on two things: humidity and the source of the charge. Low humidity makes it easier to generate static. And if the source is made of plastic, the charge can be even greater. In fact, most synthetic materials are insulators. They prevent the free fall of electricity by trapping the charge on the surface. On the other hand, paper, cotton, and wood are safer because they tend to absorb small amounts of moisture from the air, which makes them neutral. So with the right combination of factors, we can all create static discharge. Common activities like picking up a plastic cup, opening a notebook, or walking across the room can easily build up enough static to give you a small electric shock, and most shocks are at least 4,000 volts. Look at what 4,500 volts did to the inside of this integrated circuit. Under high-powered magnification, you can see its damage beyond use. We call this kind of damage catastrophic. Because of its severity, catastrophic damage is usually detected in the testing stage. But sometimes the damage isn't so easy to find. Sometimes microscopic scanning or dynamic testing can't even detect it. We call this latent damage because it can slip past inspection and cause big problems after the component has been put into service. Even as little as a few hundred volts of electricity can damage some of our high-tech products. 230 volts is enough power to seriously damage a surface acoustic wave filter. Even smaller charges are a threat to a gallium arsenide field effect transistor and a 1N5711 diode. You can see that this is pretty serious stuff. That's why at Motorola, we've categorized our electronic assemblies according to their sensitivity to static. There are 5 classes, starting with the components in Class 0 that can be damaged by just a few volts, to components in Class N that can withstand charges of more than 16,000 volts. The production areas of these different components are designed according to the safety requirements of their product classification. We have also written a comprehensive manual on how to prevent static. Here's a quick rundown of what you need to know about your certified ESD protective workstation. First, we have to follow specific guidelines when handling electronic components. For example, all printed wiring boards must always be handled by the edges. ICs have to be held by their body and avoid touching the leads. Second, we have to monitor the work area's humidity level and temperature at all times. On dry days, when relative humidity is less than 25%, we use humidification or ionization to prevent the possibility of a discharge. Smocks have to be worn when we work around static, sensitive items. Our own clothes cannot extend past the cuff. We also have to use a wrist strap connected by a cord to an appropriate common point ground. Make sure you don't let tape or clothing come between the strap's contact plate and your skin. Plus, just to make extra sure, straps and cords have to be checked at the beginning of each shift. And don't forget to document these check tests. Unless, of course, you use constant wrist strap monitors. If dry skin is a problem, apply an approved lotion onto the strap. If you're handling sensitive components without protective containers, or if you're not grounded with a wrist strap, make sure you're standing on conductive or dissipative flooring or an approved floor mat. You also have to use conductive footwear. The foot straps must be kept clean because dirt and grime reduces their effectiveness, so they cannot be worn outside of the work area. The safety features of a certified ESD protective workstation include static, dissipative, or conductive work surfaces. Charges on items placed on this work surface are drained to ground. But regardless of these precautions, ungrounded people and other prime static generators must be kept out of the controlled area. Unfortunately, it's difficult, if not impossible, to eliminate all sources of static from a workstation, especially plastic work tools. So remember to treat your plastic instruction holders, notebooks, pens, and other plastic items with an approved topical anti-stat. As you can see, Motorola is taking decisive action to eliminate ESD damage. Our thorough approach even extends to the way we package our electronic components. In fact, all packaging must be done under approved conditions. The workers have to be properly grounded. They must wear static protective clothing, and their workstation must be certified as ESD safe. There are several types of packaging designed to minimize ESD damage, including shrink wrapping, customized shipping containers, cushioning materials, bags, and boxes. Generally, electronic assemblies are enclosed in special electrostatic shielding bags. If you aren't sure what type of ESD packaging material to use, remember this simple rule of thumb. Wrap the sensitive item in static dissipative material and then surround it with conductive material. Because the outside of some ESD protective bags is conductive, never set one on top of hardware or place a component on top of the bag. And once the products are in their packaging, apply an ESD warning label on the bag or box. When using an ESD warning label to fasten a shielding bag, make sure you securely close the bag by folding the top over. And be careful not to let the components come into contact with the label. When opening, always peel the label away from the flap, towards the bottom of the bag. Before taking the item out, make sure the label is not attached to the bag's open end. As a result of all these steps, our products are sent to the shipping department, safely wrapped in specially designed packaging and clearly identified as static sensitive items. The message is shockingly clear. The way we handle our complex high-tech products is a critical issue, an issue that has a direct impact on our reputation as a best-in-class electronics company. Each and every one of us has a role to play in the elimination of ESD damage. With this training, you are now part of the solution. You too can create a static-free workplace.